Okay, perfect. So I'm going to share my screen. Let me know if you can see it. Hi. So you all can see the screen, right? Let me check on my YouTube app as well if the comments and everything are right. Okay. So Ishika, shall we start?
Yeah, sure.
Okay. I'll send you the link of the meeting on WhatsApp. Okay. So let's wait for a few seconds. After that, we're going to start so that everyone can join. All right. I think we should get started. All the people can join over time. So hi everyone. Hi everyone. I'm Tushar Ojha, and today in this session we are going to learn about blockchain and Web3, like the most popular terms right now. And if you are in this tech space, we have heard a lot about these. But if you are still wondering that how can I get started, what it is actually, you are missing about some fundamentals of it. There's a It's basically like if we call it as Web3, then it's the next internet. Then how does it work? What are the key fundamentals which you must have before moving on development on this process? And what are all those things which you need to learn? So that whole lot of things are covered in this session. It's full packed. Now we're going to start very soon. And in this session, you will be able to get a lot about the right path and the foundation for blockchain. After that, you can build your own decentralized apps, you can build your own blockchains, and a lot of things could be done after that. But this is for those people who have heard a lot about blockchain but don't know what it is actually and how it works and how you can also be a part of this blockchain journey. So special thanks to IEEE MSIT for organizing this session. A little bit about me. I'm Tushar Ojha. I'm an open source and tech enthusiast, and I'm also a student at MSIT Delhi. I'm working on my projects called GiftaMatic, which is a blockchain-based donation platform, and also Educate app, which like provides free education to everyone with no distraction by giving them a platform where they can learn from their YouTube playlist and everything. Also, I'm a grant recipient from Polygon DAO and a scholarship recipient from Harmony. So there are a couple of things more which could be done, and I'm working on right now. So happy to see and connect with you all. So this is the agenda for today's session. We'll be learning about what is blockchain, what are cryptocurrencies. You have heard a lot about it. There are tons and tons of cryptocurrencies, which one to pick, which one to trade. Those things we are not going to discuss, of course. What we're going to discuss is about cryptocurrencies, how these works, what are they. We'll also think about how Bitcoin was discovered, what Satoshi Nakamoto did, what he proposed. We're going to understand about wallets, public key, private key. We're also going to understand about like how transactions works, and how things are beyond these cryptocurrencies. Blockchain is not just limited to these cryptocurrencies, which you might have heard already, because get rich quick schemes are getting more popular over time, but not the core technology itself. So we're going to talk about Ethereum with Alex's perspective of blockchain, smart contracts, how you can write those, what are these. We're going to also talk about a trilemma, which is called blockchain trilemma. We're going to talk about some other chains which are also available. Ethereum and Bitcoin are not the only chains available in the market. There are tons of chains like layer 2 solutions, for example, Polkadot and others, Solana, Near, Polygon. So all these are different chains, and we're going to study about those. We're going to talk little bit about NFTs and metaverse. So there are a lot of things, but let's see how much we can dedicate time on each of those. And I can see your chats, by the way. So if you feel like you have any questions or you want to discuss about something, then feel free to message. And after that, let me know if we can get started on this. You can just comment hi that let's go, and we will get started on this journey. Okay, I think we should get started without wasting any further time. So that's the agenda. What we are not going to discuss in this session is also pretty important. We are not going to discuss how many jobs are there in the market for blockchain. We are not going to discuss that it's more than $1 trillion economy. We are not going to discuss that the average package in India for blockchain developers is 60 lakhs per year. We are also not going to discuss that the trajectory of the graph between internet adoption and the blockchain adoption. So there are tons of things which you're also not going to discuss. If you know them already, then it's good, but it's also good. No, it's also okay the otherwise. So hi Naman, I just saw your comment. So okay, so we're going to get started this way. If you have any questions, you can ask. There would be an AMA session at the end of the session. During the session, if you feel like you have a certain question, just comment those down. I'm going to read it on the way. All right. Now let's talk about what is the blockchain. This is the definition which I've picked from the internet. So most of the definitions you see on the slide have been picked from the internet, but in this session, we're going to deep down and understand what these actually mean. So blockchain is a system of recording information in a way that it makes it difficult or impossible to change, hack, or cheat the system. So blockchain is essentially a digital ledger of transactions that is duplicated, distributed, and across the network of a lot of things. So for you to understand, you have heard about and you have probably used LinkedIn as a data structure. So it's kind of a LinkedIn. And how does a LinkedIn look like? There's a hash of like there's an ID of that particular node, and it also stores the pointer address to the previous node. So that's how it works, right? On a LinkedIn. In a similar way, blockchain works the same. But additionally, blockchain uses cryptography to generate some hashes so that it can protect the data which it holds, and also at the same time, it's decentralized and there is a consensus mechanism attached to it. What does it mean? So think of for an example, think of a linked list which you have created, which is full of data at certain nodes, and you have also hashed those data so that you can make it a bit secure. Like generating a hash is a problem for humans to understand, but let's say you have generated a hash for all the blocks and you have linked all those blocks, and this is a blockchain for you, but it's not distributed means that all the nodes are essentially the computers which hold the same data, and also you can call them as miners. So if all the nodes are holding the same blockchain data which you have and are trying to add a new block to it, and so they are all coming to a consensus that this is the version of blockchain which is accurate and which is acceptable by most of the nodes, right? So for example, if I have something written on my page and everyone else also have the same thing, so we can all come to a conclusion that yes, like this is the truth, this is the real truth. So in a similar way, blockchain works. So in blockchain, we are distributed, and but we also try to make consensus. So that's what consensus means: agreeing upon to something. So the nodes which does not agree upon something are the ones which got discarded, and they don't end up making some money. How does that work? We're going to understand. But on an overall basis, you should be able to understand it's kind of a chain linked list with hashing and securities, and it is distributed across the systems. And all those systems come to a consensus about the real truth or the source truth. All right. Now, actually, let's take a deeper look into a particular block. That what does it include? What are the different parts of a blockchain? So, for example, we know if we talk about, let's say, Bitcoin or all these blockchains, Bitcoin blockchain or Ethereum blockchain. So, a particular node in that blockchain holds
ज्वाइन
some
कर लो
data, right?
सारे
What are the
साथ जल्दी से
properties of that particular block? So, let's
तीनों फोन से ज्वाइन
open
कर लो
this particular block and see what it contains. So inside a
मेरे
block,
ये
you
जा
can
रहा है
see
तब
I've
का
zoomed it out, and so if you zoom out
टीवी ऑन
something, the
कर दो
pixels go away. Like you can see a lot of pixels.
जल्दी करो
So it was pretty clear in this image, but now we got a little less designs.
आई ट्रिपल एम एस आई
So
के
in a
साथ
block, you have a block header and a block body. Block body contains the data about something. Something we're going to talk about what that something is, but assume for now that it contains some data, and the block header contains the previous hash. Previous hash means the block which was previous. Let's say this was this one. So it contains the hash of this block. It contains the hash of itself, and it contains a nouns. We're going to talk about what nouns is in very deep. Usually people don't talk about these terms, but these are very important, and these will help you understand how things work. So depending upon how much interest you're going to show across the session, we're going to take a deeper look in all these and try to build a good fundamental for blockchain development, because that is the most needed thing to get all the things which we did not discussed earlier in this session, if you are following from the start. So we're going to talk about nouns. So there's something called nouns, which is there. It's basically a number, let's say 457 1932, some kind of a number. There is a timestamp, that the timestamp at which this block is being created, and there is a Merkle root. So there is a Merkle tree. How does a Merkle tree fashion? If you have studied in like data structure algorithm, it's really good. But in Merkle tree, let's say if you have a data and then you hash it, so it becomes the root. It becomes the node of that Merkle tree, and then there's some, like, just think of two data points, and then you combine those hash and generate a new hash. So that becomes the root node, and that's how you continuously grow up a Merkle tree. So that's what it is, and it contains a Merkle root for all the data points. So that's it about what is inside, what resides in a blockchain. So we are already clear that there is some data. What it is, we're going to cover later on, but this is clear. What is also clear, the previous hash, block hash, Merkle root, and the timestamp. Not talking about the nouns. So to talk about the nouns, it's very important that we understand how does mining work. So nouns is something which would be a major concern for the miners, but not for us. What I mean by that, let's look at it. So for a blockchain to work, there are different nodes. As I already told you, that there are different nodes distributed across the globe. So all these nodes have to do something to add a new block. So all these nodes are basically working on a consensus mechanism. So these consensus mechanism, like there are 50 plus consensus mechanism I have heard so far, but the one which is, let's say, Bitcoin is using is called proof of work. How does that work? So all the nodes have to fight for something, or have to fight for a mathematical problem to achieve, like to solve a mathematical problem. The first node to solve the mathematical problem is going to be the node who's going to add a new block to the blockchain, right? So on the pen and paper, we all basically have a linked list drawn, right? So the first person who's going to solve a maths problem and then add a new node to it would be the truth node, or would be the correct node. And all the other recipients, all the other nodes are going to also generate it over time. They might take a few more seconds, a few more minutes, and after that they are going to validate this particular block, that this is a correct block. And then that block is being added to all the nodes, all the copies which the nodes are having across the distributed system. Are you getting it? Are you following? So what's happening here is that, how does mining work? So for example, we already understand about the blockchain, that there's a distributed public ledger which is there. To add a new element to this blockchain, to add a new block to this blockchain, what we have to do, we have to add basically all the nodes. Let's say you requested to add a new transaction, you requested to add some data to this blockchain to all the nodes. So all the nodes are going to fight to solve a mathematical problem which is associated with it. And those mathematical problem, the one who is going to solve that for the first time, like the one who is going to solve it for the fastest, is going to add a new block. He's going to add the new block, and all the other nodes in the system are going to verify this node, and then they will going to add. So over the time, as soon as like new blocks are keep on adding it, the difficulty to remove a particular node or change some data would be difficult, right? Because the hashes are going to be added upon and upon and upon and upon. So this is very difficult to change some block which is quite older. So as a block gets older and older, it is difficult to change some data in it. So that's how the security goes. So that's how there are different people. Like usually, if a transaction goes up there, it usually takes 2 3 blocks to be added after that, so that you can confirm a transaction, right? So block solves a problem which we already understood, and then they validate also. If they were not able to solve it for the first time, they're going to validate it for the others. They get the mining rewards, which is very important. Paisa hi paisa hoga, because let's say I made a transaction between me and my friend. So I have to pay some transaction fees, right? Which is different on different platforms like PayPal, centralized platforms, bank fees, and tons of like that. So bank fees and all those takes the fee to run their systems. In a similar way, blockchain also takes the fee called gas fees. So if you make a transaction between you and your friend, you pay some little extra amount which is required, which depends on the network congestion, that how much people are active right now and how much people are transactions are there. Why should they pick your transaction on priority? So you pay depending upon that, and that amount gets to the mine. That amount plus a new mine they are going to do. What that new mine I'm going to tell, but plus that amount is going to be transited for that node owner in their wallet, right? So what that new amount is, for example, if you are starting a Genesis block means on a blockchain, the first block, right? The first block, the person who is going to create the first block is the creator of the Genesis block. He's got all the tokens, let's say, or X amount of tokens. So that tokens come into circulation as he is going to transfer it to someone else, someone else, someone else, and so on. So in a similar way, they are fixed. For example, for Bitcoin, there is a fixed X amount of tokens which could be Bitcoins could be mined. So let's say there are 90% of the Bitcoins are already mined, right? For the remaining 10%, these Bitcoin are going to mine over time. Plus, and those would be coming to as a reward for these miners to solve the problem, storing a copy, validating, right? And additionally, let's say when these get exhausted, all the 100% of the Bitcoins are mined, then only the reward they will get is the amount you pay in the gas fees, right? So that's how it works. If you think on a deeper level, you will be able to understand further that how does it actually work for as the price increases, and there are tons of things coming up. But for now, you can understand that the reward a person get is the gas fees plus the mining they have did about some extra Bitcoins. So that mining reward also changes over time, over every 10 years, every 5 years. This is changed according to a certain algorithm which is different for different chains, right? And the solving the problem is the part of a consensus mechanism, solving problem validation. So all of these blockchains run on different consensus mechanisms to understand. um, okay, I just got to know that the screen share is stopped. Hi, can you all see the screen now? Okay, perfect. So this is how mining works. Now let's move a bit further. But before that, congratulations, you understand the basic fundamentals about blockchain, what it is, how it works, what are miners, what are nodes, what are rewards, how does a block look like, what are hashes, what is Merkle tree, and a couple of things you have already learned. So that is really amazing, and it's worth having a clap for you. So tell me, how is it going right now? Are you able to understand it? Should we move a bit slow? Should we change the language to Hindi, or any way you are feeling? If you have some questions regarding the previous slides, which we already discussed, like what is nouns, you are not able to get it. Oh, did I explain nouns? So yeah, let's see how does the nouns look like and how it works. So what I've opened up here on Chrome maybe, yeah. On here, I have a blockchain demo. So in this, we're going to understand about a nouns and how hashing works. So this is what called hashing. So let's say I have a message here. I have a data. Let's say my name. So this is the hash for it. There are different hashing algorithms. The right one, the right now we are using SHA 256. So let's say in a block we see. Sorry. Let's say if we go to your block, these are the three, four things which we have inside a block: the hash of the previous node as well, and nouns, data, and the block number. So let's say we are on the Genesis block, so there's no previous data. But if we, let's say, move to a further blockchain, we'll have a previous data, a previous block hash as well. Let's say I have entered some data to Tushar Ojha. Okay. So for this particular data, this nouns is not correct. So to generate a hash, we saw that, let's say, the hash right now you can see here for this data is this Tushar Ojha. This is the hash. But now the mathematical problem which are associated is something like, um, the first node who is going to generate a hash by adding any extra value, like by changing this nouns in a certain way that the first three, let's say the first three letters are a zero, right? Now I announce this problem. So all these nodes are going to change the value of the nouns such that they are able to generate a hash that starts with three zeros, for example. So if I click on mine, this is how it looks like. So the problem was for four zeros. So they changed the nouns value to this. And now you can see that this is the hash generated with the four zeros, right? So they have to change this nouns value in different way. So that's how mining works. That's how the computation power is required. So more the computation power, more easily you will be able to get to this hash. The first person to get to such a to get to us to get such a hash is the one who's going to add it to the block. So especially, like, you can think of it like they have to find this nouns such that the hash would contain starting five zeros, six zeros, depending on the blockchain. It might be different. For example, I'm going to show you a Bitcoin. This is the Bitcoin white paper, for example, if you want to learn, but we're going to talk about it later on. So for example, if you see on this Bitcoin Explorer to see a particular block and what the data it includes, so you see on the hash, it has this much amount of zeros. So if I do in the blockchain demo, if I was able to change this problem to like how many zeros I want in the hash at the starting, then the time it takes to solve this would be very different, right? So that's how the nouns matters and the nouns value differs. All right. Let's move forward to this. We were inside a blockchain and we have just understood what a blockchain is. Awesome. Perfect. Okay, now what is the next thing we're going to understand here? Now, what's the next thing we're going to study? The next thing we are going to study is what are cryptocurrencies. So cryptocurrencies are one of the hottest topic which you might have heard in the past 2 3 years. People are buying it, people are selling it. It's getting banned and unbanned, and Supreme Court orders in India and all across the world. People are saying Bitcoin rises to this point. I lost the money. People doing suicides. A lot of things are happening right now. What our concern is that we should be able to understand what actually a cryptocurrency is, why it was required, what capabilities it opens to us, and what is the real use of these cryptocurrencies. All right. What are these? What are the utility of these cryptocurrencies? We are not going to think about which one to buy right now because that doesn't matter anyway. You will still going to lose money. So the cryptocurrency, the most famous, the most expensive, and the most valued right now is Bitcoin. Bitcoin is a cryptocurrency, right? It was introduced in 2008. It has a fixed total supply. It needs some computation, like it is backed by computer time and power. So if, let's say, I ask you today that you have to create your own currency, how do you imagine that currency? What are the properties of such a currency would look like? Think about it. If you are supposed to create your own currency, like we have Indian rupee, we have dollar, we have ruble. So if you were going to create your own currency, what were the key properties that are going to matter? All right. If you have some ideas, then you can chat, message those on chat. But I'll get started by telling, like, get started. So the first one is that all the, let's say I'm introducing a coin, my currency would be in a form of a coin, then there should be a fixed supply of those coins, right? It should not be something like I'll be able to generate as many as coins as I like. So then if something is infinite, then people are not going to value it, right? If you can generate any amount of your coins, Why would people buy it? People can also generate. Other thing is that this should be acceptable. This should be usable. Actually, like people should be able to accept this currency for a transaction. It should be something which is backed by something. For example, our Indian rupee is backed by our gold reserves. Most currencies are backed, like centralized currencies are backed by some gold reserves, right? Because gold is limited on the earth. Some metals that are limited on the earth. So that's how these currencies are backed. So in a similar fashion, there should be something which is backed for my currency. There should be some authorized authority to validate about a currency that it is correct or not, and the transaction that is being made through this currency is correct or not. For example, if you see on a rupee note, there is a clear mention about the governor saying that I authorize that this person is giving him this amount of money, something like that. So there should be an authority. Now, coming this like taking this all together for a cryptocurrency, we do it in a similar way. We have all those similar terms, but in a different manner. For example, the authority, the governor here is the community, is everyone. All the nodes are the governor for that cryptocurrency. They are going to verify a particular transaction. If you are paying someone 100 bitcoins, you should have 100 bitcoins in your wallet, right? So that is being verified by all the nodes. They are going to check for your balance. They are going to verify a transaction is correct or not, right? And what is backed? We don't have gold to back our cryptocurrency. We have computer time and power. So Satoshi Nakamoto, who introduced Bitcoin a long time ago in 2008, already knew that computers and computer power is essentially one of the most important things. It's as important as gold. So why not to back a cryptocurrency with this computation power and time? This is going to add on to its security. Like no one can create their own gold, right? If there is X amount of gold, then it is, no one can create a gold, right? In a similar way, the computer time and power which have been spent, no one can copy that. So even if they want to copy, they would have to take over, like since it's decentralized and it's using consensus mechanism, they have to take down. If an attacker wants to take all the bitcoins and want to change some data on a blockchain, then they have to change for most of the nodes. For example, 10,000 nodes are there, they have to change for 5,000 nodes, more than 5,000 nodes, to come to a wrong consensus, right? So that is technically not possible. Even if it does so, Satoshi Nakamoto says in the paper that the person won't going to change something, like he's not going to change the transaction data, but he will try to mint some new bitcoins, because that would be more valued. If you change some data on the previous blocks, then people are going to stop value it, right? The Bitcoin value goes down, because the value of a currency matters on the demand and supply. So this is also very important. That's why all the supply have been controlled for Bitcoin through programs, through computer logics. So it is already unknown that how much Bitcoins will be minting in the next year, in the next 5 years. So that's how it works. And that's how Bitcoin works. It works on the very similar thing, but on a decentralized fashion, right? So that's what a cryptocurrency is. It's not backed by, it's not authorized by a central government, because let's say India can decide to mint 1,000 more, 100,000 more, 2,000 rupees note. No one can do anything about it. But on Bitcoin, it's not possible. It's not possible because computer logic is already being written, and most of the nodes in a decentralized fashion are running that code. Screen share stopped again. I get a comment from someone. Sir, I have a doubt. What basics to learn to get started with the Web3? That's what we are discussing right now, Kusum. Actually, we are discussing about what is blockchain and the basics which you need to get started to Web3. That's what is going on in this session as well, right? Just making sure that the screen is sharing again. I'm able to see the screen. So we are discussing about the same, that how you can get started on blockchain development. What are the fundamentals? Actually, we are covering it, what blockchain is and everything. All right. So we talked about what blockchain is. We talked about what Bitcoin is. Now let's talk about, there are two types of cryptocurrency. One is called token, one is called coin. So you have heard a lot of time these are being interchangeably used, or some people call it token, some people call it coin. So let's understand it. For a particular blockchain, for any particular blockchain, the currency in which you pay the gas fees, let's say, the native currency of that blockchain, the currency in which you pay the gas fees, in which the currency which you need to, in which the miners are getting rewarded, is called coin. For example, For Ethereum chain, the native coin is ETH coin. So that's the cryptocurrency. It's a coin. Ethereum coin is a coin on Ethereum chain. But let's say if it is Ethereum is similarly available on a different chain, then on that chain it would be a token. So for example, Shiba Inu is a token, not a coin. Shiba Inu don't have their own blockchain. It is on the Ethereum blockchain, right? So it is just a piece of code called smart contract, which have different methods to transact, transfer, allow approval, and a lot of things that makes it a coin and makes it work as a cryptocurrency, right? So anyone can create their own cryptocurrency on Ethereum. That's what I mean. But let's say if you want to transfer Shiba Inu to someone, you will be needing um, Ethereum to transfer it, because you will be paying in the gas fees in Ethereum. So it is something like people today, you can think of US dollar as a coin, and most people, like even I would say, for example, Russian coin, Russian money. Let's say Russia wants to transfer to Ukraine to help them, so they would need to pay um, in their currency, their token, but that token gets to be converted. Like they have to pay the gas fees, the all those fees in US dollars. A very stupid example, but that's how it works, right? The token is a contract, it's a code which works like a cryptocurrency, but it is on a chain which is not the native chain of that token, right? I hope that was clear, but let's see. You will get the clarity on it over the time as you create your own tokens. So it is very easy to create your own token, but to create your own coin, you need to run a new chain and to maintain all the nodes and maintain decentralization. We'll talk about that now. So, perfect, the template. So now we're going to talk about wallets. Before that, if you have any questions till now, what we have studied about blockchain, about Ethereum, about tokens, cryptocurrencies, then you can ask. After that, we're going to talk about wallets. What are different wallets? How to create one? What are public key and private key cryptography? And a lot of things like that. All right, then if there's no question, we can move forward and understand about the wallets. What are wallets? Why wallets? Why wallet is pretty clear. So what are wallets? If you talk about a wallet, so you got some bitcoins, but you need to store it somewhere, right? If you have 10,000 rupees, where do you keep it? You keep it in a wallet, right? You keep it in a safe. You keep it in a hardware kind of a locker. So that is your wallet in simple terms. But in cryptocurrency, it works the same way. If you have 10,000 bitcoins, where would you keep it? You keep it in a wallet. That wallet could be a software wallet. Wallet could be a physical wallet, right? That could be a hardware wallet. There are a couple of wallets which you need. Now, what's different is that you will also need to pay. When you need to pay someone, you should be able to open that wallet. You should be able to sign a transaction. So that's what a cryptocurrency wallet look like. It's basically either a device, physical device, through a medium, or it could be a software wallet, for example, MetaMask, and which stores your public key and private key. So what these are going to understand right now, but it stores your keys, which have some values or cryptocurrencies on the blockchain. So the tokens you have are the tokens you have is stored on the blockchain, but to which address each token is stored on the wallet. So I'm going to talk about right now. So there are two things: public keys and private keys that are being stored in a wallet. You need these public keys and private keys to sign, receive money, pay money, and a couple of things. So that's what a wallet is. For software wallet, you can think about MetaMask and these wallet extension, browser extensions, which you get. And there are hardware wallets as well, for in a form of a pen drive, let's say, and you can use those to store your public keys and private keys. What these are, let's understand. Before that, there are two types of wallets as well. They are custodial and non-custodial wallet. So custodial wallet means that you are giving custody for your wallet. You are not good enough to store you are good enough, you are not good enough to secure your public keys and private keys or your wallet at your home, so you give it to a bank or something. So in a similar way, custodial wallet means that you are not you don't have the authority, you don't have that ability to store or secure the keys by yourself, the wallet by yourself. So you give it to someone else, and they will store it on your behalf. So it makes the whole thing centralized, so it's not recommended. But for example, if you are trading and those stuff in your fiat currency, then people use these types of wallets. For example, WazirX, Coinbase, these all storer wallets, which we call custodial wallet. Non-custodial wallet means that you are taking care of the keys. Your wallet, you are taking, make sure that the your wallet is secure. It's your private key cannot be seen by anyone else. So yeah, because if you lose your private key, you won't even know who can use your money, and you cannot call to any customer care because there's no customer care in the crypto world. Let's understand about public keys and private keys, because these are one of the most important part of any cryptography and anything we do. So there are two types of keys, which is called public key and private key. By the name suggests, you can share your public key but you cannot share your private key, or I would say, but you should not share your private key. These are used to encrypting and decrypting some data. So you can think of, like, if you have a private key, then you can generate a public key from it, right? But if you have a public key, then you cannot generate a private key from it. Are you understanding? If you have a private key, if you have a private key, then you can generate the public key associated with this private key by doing some maths. You can do it on paper, or you can allow a machine to do this math. And after this math, the machine could generate a singular public key for this particular private key, right? But it's not possible to do it vice versa. You cannot generate a private key from a public key. So what's more important? The private key is the most important thing in cryptography, and you should not share your private key with anyone, right? People also believe that uh, your key is basically your public key is the address, but it's not true 100%, but for most cases it is. You can think of it like, I want to send 100 bitcoins to my friend. How would I send it? How do I make sure that my friend is receiving it? So my friend is going to share me his public key, like, this is my public key, take it. I copy his public key, and I then send my money to this public key, and he's going to receive it. So whenever he needs to spend this money, he's going to use his private key to spend the money, right? That's how it works. On the blockchain, if I would like to show you something, I can show you right now. So for example, this is the public key of my account. I'm pretty I don't have much money, but yeah, this is the public key of my account. If I want someone to send some money, they can use this public key. Like, I can just copy it and share it over socials or the particular network, and then they can send money to this network. Now I'll be able to spend this money because I have the private key of it. And on blockchains do not store the balance of each account. For example, this much balance this account has, this much balance this account has, but the blockchain stores the transactions that 10 bitcoins are transferred from this key to this key, this public key to this public key. You can see it here. For example, there are this public key, um, this public key send money to this public key, which is 5 matic, right? 5 matic cryptocurrency. That's how it works. That's what is being stored on the blockchain. The blockchain is not going to store that this key have this many tokens or this many balances, right? So it just stored the transactions. So according to that, if let's say you create your own public key and private key pair, right? And if you create that public key private key pair, and you can on a paper which is not connected to internet at all, then you can still share that public key to someone that take this public key and send all the money to this. They're going to send the money to this. A transaction would be registered. It is not going to check if that account exists or not. It cannot actually check that. So it's going to send the transaction to that particular public key. If you have a private key which is correct, which is going to generate this public key, you can use this money, else you cannot, right? So that's the beauty of cryptography, that you just need a key, and there's an algorithm to which you pass the key, and it's going to verify that you are the owner of this account. So you don't need to fill any forms, you don't need to go to any bank office, not of course in the lunchtime, but you don't need to go anywhere else. You can just do the math if you are good enough on a paper to generate a public key and private key, or you can use some machines. For example, I have this MetaMask wallet here. So if I want to generate a new account, I can just click create an account. I'll enter some name, test account. I click create. Boom, the account is created for me. This is the public key for this account. I can also open up here. So if I disconnect the internet, it's still okay with that. So this is for this address, this public key. There are no balances and anything else is not there. But let's say if I go up here and I click here and I click on account details, I can export the private key from here. I can click here, enter the password, which is basically stored in this wallet itself. It's not something like this data is being stored on the internet. It's completely offline. So I enter the password and I'll be able to show you, wait a second, show you the private key for this account. So this is the private key for this account. If you want to use it, but just make sure that it's on the live, so none of your balance is going to stay safe. So that's how it works, right? In a similar way, you can think of it like if we were building some chat application, then how would I send a message to Bob? So Alice wants to send this message. He said he wrote this message. Then he used the Bob's public key to encrypt this message to something like this, which you cannot read. It's called ciphertext. And when Bob receives this message, he uses his private key to decrypt this message to read what Alice said. And Bob can also verify that this message was sent by Alice because he also have the public key of Alice, right? So you can see that the public key is entered. It was signed by this public key. So that's how this whole work in a mathematical format. There is something called mnemonic, which I am giving you as a homework to understand what mnemonic is and how it works. So for a basic example, you can think of there are 12 letter words, 12 or 24 different words. For example, car, bat, cat, rabbit. So I'm just naming a few things. So there are dictionary words are there. So in a particular combination, 12 words are picked. And from that combination, you can generate any number of public keys and private key combinations. So that makes you eligible to create a multiple account. So when I created an account here, it was generated through that particular mnemonic itself. From that mnemonic, all these accounts exist, right? All these accounts exist from that mnemonic. It generates multiple public keys and private key pair. Okay, so that was it about public key, private key. If you have any questions regarding this, you can also ask. And after that, we'll move forward. We'll just check the chats quickly. All right. If we don't have any such questions, then we can move forward with the next part. I'll have to check what's the next part. Okay, so we're going to talk about thinking beyond cryptocurrency. Blockchain is not limited to cryptocurrency. That was one of the belief which Ethereum founders had, that blockchain could be used for much more things than just using it for money and like payments. Payments is one of the subset of the usage of blockchain. There are a couple of things more which could be done. That's what we're going to discuss now. Let's go ahead. So what is Ethereum? We're going to talk. These are the founders. Ethereum founders, like the left one you see is Vitalik. On the right one you see is Gavin Wood. So what happens is that Ethereum founders saw that blockchain is good, Bitcoin is awesome. I'm able to make money. I'm able to do transactions. I don't need a central authority. I can send money from India to any country in the world to like similar way. We can send money. And there are nodes which have some computation power, which uses some computation power to process these transactions, make sure these transactions are secure. But then they thought, like, these are real machines which are running, right? We are calling them as nodes, which these do have the full environment to process literally anything. They can run code as well, right? They are already running certain code, but what if we are able to run some, we are able to create an environment where people can program, and that programmable code is going to be running on these nodes. So basically, there is a certain Bitcoin code which is processing and which is able to run across the nodes. But what if we would be able to create some kind of a new blockchain in which people can send some programming code, and that programming code could be executed by these nodes? How awesome it would be. It would be something like, it would be decentralized computation power. You have, let's say, servers, centralized servers. So what happens to those servers? You write some code in your programming language, whatever you use, Node.js, Java, anything. You write that code and you send to that server, and now that server is running your code. In a similar way, what if people can run code on these machines across the world? It would be decentralized, and people can build softwares on that. People can build applications on that. So that's how the era of dApps open. dApps mean decentralized applications. So thanks to those two awesome people, and the date was 30th July 2015, like yesterday itself. All right. So the piece of code which you will be writing, and that code, like the code which is going to be executed across these nodes across the globe, is called smart contract, right? So if you have written some piece of code and you send this code to a blockchain, and that blockchain is going to run this code, whenever some conditions are met, whenever some things happen, this program which is stored on the blockchain is going to execute. So that is what we call this particular code which you send is called smart contract. So these are typically the use case of these smart contracts is these are short form code, like they have a certain type or certain objective to accomplish for a particular code, like a particular code file, and they run on the blockchain, right? The use cases which we're going to talk in future, but yeah. So now, since programmers are able to write some code which is dynamic, which has a lot of properties, you are able to do tons of things, then the era of dApps open. People are able to create different dApps. I'm going to tell about what are those dApps, but this is the amazing thing happened to Bitcoin or blockchain, you can say. So let's see how does a code on the blockchain look like. So for Ethereum, if you are, let's say, if you are building on top of Ethereum, that means you are writing some code that is going to be executed on Ethereum blockchain. Then that code is written in Solidity programming language, or there is called some other programming language called Viper. So Solidity is created by the Ethereum organization, Ethereum Foundation itself. So this is a piece of code which is written, and this particular code creates a new coin, creates a new token, not coin exactly. It creates a new token. How does that work? So what it does, this code, if you see, it's called a smart contract. So it starts with a contract, the name of the contract, and then there are a couple of properties. So it has something called address. It's public, called minter. People can see who minted this for the very first time. And there's a mapping from one address to a particular integer value called balances. So they have created a table of balances. So these are all the data, and there's some events. There's a constructor. So first person who creates this calls this constructor is going to be the minter. That's what you can understand from this code. There is a mint function. Mint function means creating new currents, creating new tokens. Like there's a particular token, but you are increasing the supply of this token. You are increasing the creator's balance. So it increases the balance by X amount, the amount which the creator entered. And after that, you can also send this to someone. So anyone can basically call this send function of this smart contract, which is running on different blockchains. And what it does, it checks if the balance the person is trying to send the amount should be less than the balance the person have, so that else it would be like insufficient balance. Then it transfers the amount. You can see like increases and decreases the amount, and then it throws an event so that all the people can know that this happened on the blockchain, to mark a particular event which happened. So that's how you created your own coin. People can transfer it to each other. People can use it for money. There is a person who can increase or decrease the supply of it. So that's how this coin works. It's a very naive way to create, but yeah, it's a very short form in which I can explain you a smart contract. So that's why I use this image. Is it clear to everyone? Just yes or no. That would be good enough. And then we'll move forward to see what kind of dApps which people are able to build with this beautiful programming language called Solidity, and what Ethereum opened opportunities for all of us. All good? Are you able to understand till this point? Everything's going well? Okay, perfect. Happy to hear that. It's clear. So we are going to talk about, with Ethereum getting announced, with smart contracts, These are different types. These are some of the types of dapps, or the applications, decentralized applications, which we're able to hear. There are DAOs, games, metaverse, NFTs, DeFi, tokens, DEXs. So what are all these things? Let's have a brief look at what these mean and how they are created through smart contracts. There's something called DAOs. DAOs, the full form of DAO is decentralized autonomous organization. So we have organizations like we have Google, Microsoft, Amazon. We have some other non-tech organizations. So we have companies registered. All those organizations have people working on something, and the person who holds the most equity, or let's say there are different roles, and there's a hierarchy which is there in all these decentralized organizations. All these are normal organizations, but decentralized organizations like DAOs, people are holding some tokens of that particular organization. So if they hold those tokens, they are a part of that organization, and now they got voting rights, they got governance about this, which thing to work on. They can vote on, let's say there is a new proposal coming, everyone can create a new proposal, that let's say we are going to do this thing from the next week, in the next sprint. They throw that proposal to the people, people can see that proposal, people who hold the DAO tokens can vote on the proposal, and the proposal which got the most vote is decided to work upon, and there people are get started working on. So people are working in a decentralized way, and it's not like the the way centralized organizations work, where there's a boss, there's a person who told you what to do, and you don't have the ability to decide what you can do. So it's very different from those, and that's why it's called decentralized autonomous organizations. So all the logic behind how a proposal is being created, how people are going to vote and do all the stuff, is written in a smart contract, something like this, which we have already seen. So you can, if you, let's say, know how to write this code, like you know about the solidity syntax, then you can basically write such smart contracts, right? And you can create your own DAO, and you just need people to hop in and just build something. There are games, people are able to create games. I've seen people are creating some chess game. So in that chess game, what happens, like both people come. So smart contract is essentially a contract which is trusted, because we can see the code of it. Okay, so this is the code which is running this, which is running on these nodes. So I can trust this. I may not know the person on the other hand, but I know this code, right? So how, let's say we play a game together, and to I ask you to, let's say, play a chess game, and the person who wins is going to give the other person. So the person who loses is going to give the other person, the winner, 100 rupees check. But as soon as we started playing, I don't know, since let's say I don't know the person, so he might cheat on me. How would I know that he's going to? How would I assure that he's going to give 100 rupees if I win? So that thing, that safety and that trust could be generated on code. So like, I feel sorry to say that people have lost trust on each other, but they trust on the code, because that is something which is, they have trust on machines, that the machine is going to run this code for sure, right? In a similar way, so I've seen a game, in a game of chess, in which both the parties come, they give 100 rupees to the machine, the smart contract, and then they play the chess game. The person who wins the game, the smart contract is going to transfer the 100 rupees which he deposited, and the 100 rupees of the other person. So that's how you can trust the process, and that's how the games have also evolved. It have been seen that games are the ones which bring and onboard the most people in a technology. When Web2 games were introduced, most of the people were on Web2, right? They are the first games are the first attractors to a new technology. Metaverse is a virtual world, right? You have heard a lot about it. Facebook renaming to Meta was a meme for most of the people, but the people on the blockchain understood the value and why the reason why they are doing it, why they are transitioning to Meta. So metaverse means it's a virtual world where, let's say, you can live a second life, you can do some stuff. There is a complete place you can move around, and we have already seen some games. For example, PUBG, you can think of it as also metaverse, and there are a couple of things there which we can call it as a metaverse. But the thing is that the session ends on PUBG, right? um, but how different a blockchain makes it, like, it doesn't need for a metaverse to work. For example, we played GTA, we can call GTA as a metaverse, you can play with your friends online and you can do a lot of stuff. But we cannot essentially like call it a metaverse 100%, for two reasons. One of the reason, like what Facebook is working on, is a metaverse in which you can literally go in by putting a VR headset on, and then wherever you look, you are actually a part of that experience. You are inside that experience, right? So right now, if you see play GTA 5, it's a metaverse in a 2D frame, right? Second thing is, which where blockchain powers it, is the ownership, right? Blockchain gives you the feeling of ownership. If you have let's say a cool glasses, right? So people on the blockchain, then it is verifiable. No one else can have, let's say, it's your glasses. The way you wear, it's very unique, and it's your glasses. Everyone can see that it's your glasses, but they cannot get one. They have to pay some money to get it. So it kind of acts as a social value as well, and you get the ownership on metaverse. If you have a piece of land, how do you know? Like there's a lot of land on Earth, right? You can just go on claim that it's my land, but there's a central government who's going to tell who owns a particular piece of land. So in a similar way, blockchain is the one who's going to tell who is the owner of a virtual land, a virtual store, a virtual place, a virtual clothes, and tons of things. So that's how a metaverse looks like. I can also show you a metaverse if you really were interested. So there's a metaverse called Decentraland. I'm actually inside this Decentraland for you. So if you see, I'm inside a Decentraland, and I can do a couple of things. There are a couple of events going on. There are a couple of things that could be done. Let's say if I want to go in an event, I can see what's going on, where it is, the latitude, longitude, and about this event. I can jump in. So there might be paid events and some free events. So I'm going to teleport it to this particular event. All the scenes are getting loaded, and I can enjoy it in a virtual space. And all the clothes I'm wearing are the ones in form of NFTs, which I own. Actually, I own those things. So that's how a decentralized world looks like, right? Do a couple of things here. You can meet people, you can have a chat with them, and you can see them. And you are remaining completely anonymous at the same time, right? So that's how it works. Coming out of the metaverse, we have NFTs. So NFTs is something which most people have heard about it. It's called non-fungible tokens. So if we talk about cryptocurrencies, then cryptocurrencies are meant to be fungible. That means if you have a 100 rupee note and if I have a 100 rupee note, we should be able to exchange it, right? You should not say that it's no, it's my 100 rupees note and now it's your 100 rupees note. We cannot exchange it. That doesn't make any sense. Both the value of those things are same, and those things are literally the same thing, right? So that is a cryptocurrency. But with NFTs, you can think of it as a digital art. You can think of the painting of a Picasso painted a painting. Now you take a picture of it and you just print it down. So it's not going to be have that value which Picasso's painting have, right? So by the way, if you know, can you anyone tell why Picasso painting are so much valued? It people are buying it for crores, and all those giving so much money for a painting. What's the reason? If you paint something, people are not maybe willing to give you money, but people are willing to pay money for a Picasso painting, for a good artist painting. What's the reason for it? If you actually think deep down, the reason is that Picasso died, so there cannot be any further Picasso paintings. So the supply have been already cut off. There are certain paintings, and those look beautiful and are owned by are were created by Picasso. So they have that proof that it was created by this person. And now the value of this shoots up. People trade these for X amount of values, any amount of value they can ask for someone to pay for it, and people are literally paying it. So that's how NFT work. Now I'm going to show you some NFTs which I own and how does it these looks like. So we already seen metaverse. So this is a website where people trade these NFTs, create these NFTs. So it's called OpenSea. And if I go up here, if I show you the NFTs which I own, so these are the NFTs which I own, right? I bought these three. I got these three airdrop, like free for free. And this is a ticket. Let's say there are different gated events also happen. So all the people who own this particular type of NFT are invited to this event, right? For example, this is the NFT for an event which I'm going to come. Now, if you think very clearly, if you take a screenshot of this live stream and if you try to go to the Web3 conference in Goa and you say that I'm this person, let me enter. They won't, because what they know, they have my public key and they are going to ask me to sign a transaction. So that transaction could be signed by a private key, and the person who has the private key is the actual owner of it. So right now, so you can understand the value of uh, cryptocurrency and the ownership feeling which NFTs have. People have said the memes that like just take a screenshot and you cannot enter to this event by just taking a screenshot. You need to have the private key, right? So that's how the NFTs are. It is being used for digital art forms, these tickets, and a lot of couple of ways people are using these NFTs as rewards and things like that. There's something called DeFi. Making money from money is also something which we are doing in the real world. So you can deposit your money to a bank, and then the bank gives you some interest. How does that work? How does the bank gives you an interest? The bank lends your money to someone else, right? And then the interest, the someone else, the person who got some money from the bank is going to pay them. When they return, they have to pay some interest, and bank takes their cut, and then you get some interest on your money, right? You make fixed deposits, and things happen likewise. So for all that DeFi, we have a similar thing on crypto. People can also lend some of their tokens. That okay, take these tokens, do whatever you want, and give me this much interest afterwards. So that thing also possible. People are depositing their cryptocurrency as a collateral, and people are taking getting a loan from these decentralized banks. There is no central authority who's going to do your KYC, do XYZ, and those things. You can take money, take a loan as soon as like within a few seconds. That's how DeFi works. There are different tokens and indexes. So since smart contracts enabled us to create new tokens, for example, the one I created, people can exchange these tokens as well. So to exchange these tokens, you need DEXs. DEXs are decentralized exchanges. For example, Uniswap, PancakeSwap, these are decentralized exchanges. So if I have 100 Bitcoins, you have 10,000 Ethereums. We can come to a deal that okay, I'll give you this much Ethereum if you give me this much Bitcoins. So all those things, if you want to exchange today, we have to go to a centralized exchange. But with decentralization, you don't need to go to a centralized authority. You can just do it peer to peer. So that's how all these things have been working. And there are tons of smart contracts. People are not trusting a centralized authority, but they are trusting a piece of code which have been written, which is running in a decentralized fashion, that not anyone can change this code. It's immutable. The code, the smart contract is immutable. Even the creator who created the smart contract cannot change it. So that's the beauty of decentralization. And that's how these things work. And we are able to see so much dApps coming on each day. And one of the dApp which I am working is a decentralized donation platform. So how would you trust, let's say, talking about that, how would you trust that if you're donating to someone, it is actually being received by them? So you can do it with the blockchain. If you donate 100 Matic, it goes directly to that person's account. You can see the smart contract to verify that it's going to their account. It's not getting holded any way between. So that's the beauty of decentralization plus the smart contracts. All right, that's a lot, but that's awesome. You did an amazing job understanding about decentralization. We have what we have talked so far. We have talked about blockchain. We have talked about cryptocurrency. We have talked about Bitcoin. We have also understood about Ethereum, how it was invented, what it does. We've talked about smart contracts. We have talked about different dApps which are available in the market. So that's amazing, literally amazing that you are able to understand to this point. Now I'm going to take a small break, see a few questions, and then walk ahead. There's still a lot of things which we're going to discuss, and a lot of amazing things going to come up, right? So I got some message from how to make crypto arbitrage bot with Solidity. Govinda, actually your question is good, but I cannot explain it in this particular session. I would share you some videos where you can watch about these things. So this would be like a very technical, that will go in a very technical specs, and this session is for basically introduction. So you can come to my channel, or you can ask on the relevant the Telegram groups, or if they have any groups, right? Sorry, but I cannot pick this question right now in this particular call. Even if you try to build a crypto arbitrage bot, it's going to be running on a centralized server. So if you are building on that, you just need the fundamentals knowledge, how these things work. But at the end, you will be writing the code on a centralized server. So that's not a part of this talk right now. Okay, so if you have any other questions, please do ask them. After that, we're going to move forward and know about different chains, and a lot of things is still pending, and still pretty awesome things are remaining yet. Okay, then I think we should move ahead. Let's go, and now let's talk about, yeah, We talked about how great crypto is. I shown my excitement towards it. I've shown what Bitcoin and these things Ethereum enable to us to do. We talked a lot about the good things of crypto, and but there's still few problems which Ethereum was not able to solve. We have seen so much dApps are already there, but still a few problems which Ethereum or Bitcoin and these cannot solve. It's called the blockchain trilemma. It looks like something like this. So for any blockchain, there are three things which are very important. First thing is the decentralization. A blockchain should be decentralized, right? If it is not decentralized, then there's no meaning to have blockchain. Just go to a centralized server and do the things that were already there. The second thing is scalability. People should be able to use it. There should be like the the people who are using it are going to increase over time. Um, so it should be usable. Second, the third thing is, which is also very important, is security. That all the transactions should be secure. The blockchain should ensure that no one can hamper or change. Any attacker should not be able to change some data on the blockchain. So how do you make sure that all these three are met? Because Vitalik, who's the founder of Ethereum, said that any blockchain, any blockchain, not Ethereum specifically, but all the other blockchains, none of those can come to a technology which is achieving all these three goals: decentralization, scalability, and security. There would always be a trade-off. For example, you can focus on decentralization and security, but you will be lacking with scalability. And a clear example of that, and this is Bitcoin. Bitcoin is very decentralized, and the most decentralized cryptocurrency today is Bitcoin. So that's why it's so much valued, and it's very secure. You like literally, if you need to change, even if you use your supercomputer today, still you cannot hamper Bitcoin. But it's not scalable. It takes 10 minutes to do a single transaction, even more, right? So it's not scalable. And for Ethereum, it's kind of similar thing. Ethereum is decentralized, it's secure, but to run a particular piece of code, it takes a lot of time. It takes a lot of gas fees, let's say, because of the network congestion. It's not scalable. There is a lot of network congestion. If 10,000 people come to a particular time, I told you that the gas fees would increase as per the network congestion increases. So people have to pay, let's say, if you are sending someone $20, right? It's still a good amount, like around 1,000 rupees. If you're sending someone 1,000 rupees, I ask you to pay 1,000 rupees gas fees. So how would that look like to you? That you're paying, giving someone 1,000 rupees, and you are also giving 1,000 rupees as the transaction fees. So that's the cost which people have to bear if they, let's say, make sure that everything is properly decentralized and secure. Now coming to about some other solutions, some other, let's say, there's other chains which are focusing on, let's say, scalability and security. So they lack decentralization. So if they are lacking decentralization, people are not going to trust them, because now these are being controlled by a few nodes, and attacker can change these nodes and get all the money out. So there's always going to be a compromise on one part. It's not a general truth that you have to accept, but it's a trilemma, which the idea which was shared by Vitalik. All right. Now see that you also have to accept that in future is not a single chain world. There would be multiple chains, and there are already multiple chains solving different problems, working together, and that's why we are able to hear about 50, 100 tons of tokens and chains coming every day. So we're going to talk about a few chains. So to solve the problem of Ethereum, layer 2 solutions come. For example, Polygon. Polygon is trying to solve the scalability issue of Ethereum. So in the trilemma, Polygon fits into the category of security and scalability, but lacking some part of decentralization. It's not that Polygon is not decentralized, but it's not that decentralized that everyone, like as Bitcoin or Ethereum. So that's how Polygon is. So it's kind of a layer 2 solution. What is EVM if we talk about? So if you might have heard about JVM, Java Virtual Machine. So EVM is in a similar way. It's Ethereum virtual machine. It's a virtual machine where all the smart contracts run and all these things work. So these chains you hear about, Polygon, Binance, Harmony, Tron, all these chains use the same EVM code which is publicly available on GitHub. So they use this code, write their own logics, rename about some stuff, improve in a certain parts, and then launch their own chain. They have their own nodes running across the world. For example, Binance have a lot of nodes running across Asia, Europe, and US. So these nodes are running. So this is a different chain, right? It's just a different chain. It does not share data with Ethereum. It's a different chain. It have a different block, Genesis block. It have a different native coin, that is BNB. For Harmony, it's a different chain, and everything is different. But at the end, they are using the same EVM, Ethereum virtual machine, to run your smart contract. So that means if you have written a smart contract for Ethereum, you can send that smart contract. It would work fine on Polygon. It would work fine on Binance, Harmony, and Tron, since they all support EVM, since they all run on EVM, right? Talking about other chains, so Solana is one of the chain which claims that they have solved the blockchain dilemma. They say that our chain is secure, it's decentralized, and it's scalable. It's very fast. So I've personally seen that it's very fast. Security wise, I think it's good, but how decentralized and how it is good. So like this is something they are claiming, but there's still a lot of audits that need to be there. So yeah, Solana is one of the chain which is claiming so. So now we talk about Polkadot. Polkadot is a relay chain. So the concept at Polkadot is very different. It after like one of the founder of Ethereum, Gavin Wood, left the company. He he know that he knew that future is of a multi-chain world. So he created a new chain system, and he created a completely new concepts and everything in a new format called Polkadot, where there could be multiple parachains that will be running. So that would be connected to a relay chain system, and all these chains can share some assets, share some data in between. So think of like Polygon sharing data with Harmony, right? This is not possible right now because EVMs are designed in such a way that they share only their own data. But with Polkadot, if there's a chain on Polkadot, let's say a Kala, and there is a chain called Subsocial. So both of these chains can share the assets. A particular chain can own some of the tokens of the other chain, and they can transfer these assets and all. So that's what Polkadot are. So they enable you to create your own chain for a specialized problem. So, and on that chain, people can create smart contracts. So Polkadot is layer 0 solution. Then there comes the layer 1 solutions. You can think of the chains I named. And then on top of that, there could be some layer 2 solutions or some smart contracts and things like that. Cardano, in a similar way, it also work on interoperability, interchain connections. So yeah, you can think of Cardano in a similar way, fashion of Polkadot, but it works very differently. But it's solving the same problem that Polkadot and Cardano are imagining a multi-chain world, that chain which interacts with each other, that chains that share the data with each other. Now let's quickly talk about the technologies which you need to learn to work on different chains. For example, if you want to write smart contracts there, like we understood about how blockchains work. So for blockchains, there are Golang being used for Ethereum, Polygon, and these chains, EVM chains. But let's say you are writing these smart contracts for Ethereum. We know you need to learn about Solidity to write these smart contracts. For other three, for example, Solana, Polkadot, Cardano, you need to learn Rust. So Solana is using Rust to write all the smart contracts. Rust is a programming language, publicly available, open source. And Polkadot is also using Rust for everything, literally everything. Whether you want to write smart contracts or do, if you want to create your own chain, you need to learn Rust. So that's about Polkadot, and that's it. That's enough for this particular session. We talked a lot about different things. For example, the blockchain, cryptography, Bitcoin, Ethereum, dilemma, different chains, wallets. So a lot of things have been covered. That is it for this particular session. I hope you enjoyed. I hope you learned something new. So the agenda of this session is not that you get started coding and building smart contracts right after this session. This session was intended to give you some fundamentals about blockchain so that you can, when you go ahead writing some smart contracts, you know behind the scene how all the things work. We can have a few detailed session about writing the smart contract, creating your first decentralized app, and a lot of things. If you are interested, then you can chat on it, and we'll probably create some more collaborations with IEEE to achieve that. So yeah, that's it. Thanks
Thank you
everyone
so
for
much.
joining.
Thank you so much, Tushar, for joining us. Can we have some questions?
Yeah. So,
Yeah, okay. So, my first question, how is the signature for
So there are different. I'm not sure how you like what do you meant by signature. So uh, there's something called hashing. So if you have, let's say, a data message, then there are different algorithms, SHA1, SHA256, which runs on the like they're pretty clear and how these work, open source algorithms, and then they hash the function accordingly, and then show the output. If you're talking about signatures, then how signatures work, it's also in a similar way that if you have a message and you have a private key, so you pass that private key, and like the multiple iterations which are done from the private key or the public key to generate a hash, and that hash could be decrypted, like from the public key. From the public key, we create that hash, and that hash gets decrypted from the private key. So, if you want to go depth in all these things, how actually these are generated, then you should probably read about SHA and these hashing algorithms. That would give you much more clarity.
Yeah, okay. So next question is, how are NFT related to blockchain?
Oh, so we already talked about NFTs. So how they are related to blockchain is that there's a smart contract. All the NFTs have a smart contract called ERC 721, the format they follow, in which there is a counter which is being created. So this is the first NFT, second NFT, third NFT. All of these are unique in a way. So what happens eventually is that each NFT holds some properties. For example, if it is a cat, CryptoKitties NFT, so they hold the properties like the cat. There's a cat. The cat have some rare elements, how rare it is, what breed it is, and a lot of data like that. So that is unique in the sense. And what blockchain helps in NFT, so NFT is basically a art form, right? It's an image, PNG image. On blockchain, it is also a PNG image, but at the same time, it gives you the feeling of ownership. So a particular NFT, let's say you have seven number NFT, it is being owned by Tushar Ojha. So that is what being proved here. So if you can see here, so this is on blockchain. This data is being stored on a different format, which is decentralized also. But what blockchain stores is that these properties which you see here, right, about details, and this NFT, this particular 252 ticket is being owned by this account. So that's where NFTs are related to blockchain.
Okay. Is web development is a part of Web3?
Yeah, of course. So you can think of Web3 like blockchain technology as the backend of as a backend of Web2 maybe like. So there are two parts if you want to build decentralized apps. The first part is developing a front end which uses almost like literally the same technologies which you have been learning, adding a few to those, for example, a few packages to that. But the technologies like uh, for the backend you have been using Node.js and
Basically,
all those.
it's a web backend development, right?
Yeah, you can think of it as a blockchain technology is a backend for your front end ones. So if you want to build a decentralized app, you need to know front end. You build the website design and everything, and you also write the smart contract. So from which this is being interactive, right? So these are the two parts. There is no Node.js server. There is no centralized servers. You don't need that.
Yeah. Okay, so in your introduction, you have talked about Polygon DAO and Harmony Grant. So can you tell what are those?
So yeah, sure. I've already talked about Polygon. So Polygon is a chain. DAO we have already discussed. So the DAO, which is for Polygon, it's called Polygon DAO. It's a decentralized authority organization which is intended to support the projects which are on Polygon. So my project called GiftaMatic. Matic is the native coin of Polygon blockchain, which is on. So my project GiftaMatic.org is basically I registered there and they have given a grant to this program, this particular project. So the DAO, all the organizations have a primary focus, right? That they want to achieve. So for the Polygon DAO, the primary focus is that they want to support the projects which are on Polygon. So they give money without equity to these projects so that they can build on Polygon.
Okay, cool. So my next question is blockchain an incorruptible ledger?
In
Incorruptible ledger.
Yeah, sure, for sure. Like the aim of the blockchain is the same. Most blockchains are. Um, so I would say yes.
Next question. It's lengthy. After the crypto tax, a lot of developers might be disincentivized for investing their time in blockchain tech. So, do you think there is still some scope left, and should we as students should jump into this tech when we have a lot of other options as well?
Uh, a very good question actually. So as a student, you should not you should take a look at these. Like, I understand your situation at this point, but at the same time, I would suggest that you have to make your own call. What I can help you with is learning these new technologies. What blockchain is, what these are. As a tech people, we care about these technologies, but eventually we want to make money out of it. I have made a lot of money from blockchain by learning blockchain, but you also have to, like, there are a few points which I'm giving. Decision would be of course yours, and you have to decide because no one knows the future. But everyone who's even like right now, blockchain is for developers. So if you are on this developer journey, then you have to take a step and take a decision. So I can show you some data which might help you, because I knew this question would be coming. So this is a graph which you can see right now. This is the graph of adoption between internet and crypto. So today, blockchain in 2022 is what internet was in 1998. So imagine if you were in 1998 and that time in 90s, you have created Facebook, right? People, when computer came to India, a lot of people, government officials, and a lot of people started doing strikes, and a lot of people opposed that it is going to take their jobs and things like that. People always oppose a new technology. When internet was coming to India, India also tried to oppose it because there are tons of things which the government doesn't know and they cannot control. So they are not able to adapt that. They are losing the controls. So, but you have to make a call. You can see the internet users, like the graph, the green line you see is the adoption curve of internet as eventually people adopted internet and started using it. And the blue line is basically the graph of crypto users that people are adopting and learning about crypto. So it is like the very similar graph history is repeating itself. That's why people are calling it as Web3, which is kind of a marketing term, but that's how it looks. So you have to make a call, and I'm not going to tell you that there is a 1 trillion economy. The average package in India is $60,000, but that doesn't matter if you have to pay 30% tax on it. But you have to eventually think about all this. I cannot make a judgment here.
Yeah, okay. Okay, so you know that there are many hackathons going on, and there will be an hackathons and ideathons. So any project ideas on blockchain?
Yeah, sure. So, first, you should understand the reason why these hackathons are going on. So, every month, there are 2 or 3 hackathons of these blockchains are either organizing by themselves or they're sponsoring to the organizers to organize such hackathons in which you build decentralized apps on their chains. The reason is that they have created a token, let's say Matic for Polygon, Solana Sol for Solana. So they want people to hold these tokens. They don't want people to just be a part, sell it off, and just make money and go out. They want people to hold it for a longer time. So they have to, if you have created a currency which is only for the payments, but you also have to make sure that there are more utilities to this. If you hold your money, you should be able to do multiple transactions on it. So that's why they are organizing like these hackathons, so that there will be multiple projects and that people would like to hold token to interact with your project. So the ideas I would suggest is, I've seen cool ideas on lottery related projects, smart contracts, supply chain smart contracts. So anywhere you think decentralization would be really good, or you can make something which could be trustless. So that would be good. So yeah, lottery, supply chain, donations, which I'm working on right now. NFTs, metaverse is one of the coolest and the hottest thing right now. If you could do learn about it, but that would require you some of the other Web2 things, for example, graphic design, those things. So there are a couple of things which you can do, but that's a few of my suggestions.
Okay, so that's on my
All
part.
right,
Yeah,
perfect. So we took a bit longer time, but I think it's
yeah, it's okay, it's fine.
okay then. What is IPFS? I'll talk about IPFS some other day, but you can think of it as the full form of IPFS is interplanetary file system. So let's say you want to store an image on blockchain, you cannot store an image, right? It will cost you a lot of gas fees. To store an image, divide that image into bytes, different short size bytes, and you send it to across computer nodes, which are not blockchain but have written some code and are also working in decentralized fashion. And those storage things are going to store that image, and whenever you need it, you are going to combine all these bytes to get the image, right? And you pay the rental fees for these nodes across the web. So this is kind of an ecosystem, and as per the demand, that the file gets transferred to the nearest location. So it's all in decentralized fashion. You can think of it as Google bucket or your Google Cloud bucket, but for in a decentralized format. So yeah, that's it. Thank you everyone for joining in. Happy to see you here. Keep learning, keep building, and see you some other day. Bye.
Bye. Thank you so much.
Yeah.